okay? This is, let's get rid of this thing, okay? This is called dividing radicals. Dividing radical expressions, okay? So this is real similar to multiplying radical expressions, except we're dividing radical expressions, but some of these same rules apply to dividing radical expressions as apply when you're multiplying. So if you see something like this, the square root of 16 divided by 25, can anyone tell me what that is? Go ahead, Kaylee. It's not the square root of 4/5. It just is 4/5, right? Because this can be rewritten as 16, square root of 16 over the square root of 25. So the main rule that we need to know about today is that the nth root of a divided by b, this is not on your whiteboards, this might be in your notes or just remember it, okay, is that is equal to the nth root of a divided by the nth root of b. Okay? So I'm going to do an example and then I'm going to give you, you try one, okay? So if I have the cube root of 27x cubed, 27x cubed, whoops, that should be a cube, not a square. Cube root of 27x cubed over 8y to the 6th. What perfect cube is in 27? What times what is? 3. So I could pull that outside of the box. What perfect cube is in x cubed? X. What perfect cube is in 8? 2. And what perfect cube is in y? Y to the 6. What should go down here? Y to the what? Y to the second, because there's 2 y cubes in y to the 6. You get that? Right. So we're going to try one. You try. It's going to be easy. Uh-oh. A to the 5th, the cube root, no, the square root of 25, a to the 5th over b to the 6th. Go ahead. Give that one a shot. Whoops. Can't give that one a shot if you can't see it. Tell you how to do it. Most of you got that you can pull that 25 out of it, right? And some of you got, since a squared times a squared is a to the 4th power, I have 2 a squareds inside the box, right? So I have an a squared, and I have another a squared, and then I have another a, right? Because altogether they have to make a to the 5th. On the bottom, I can only pull b squareds out of the box, so I have b squared times b squared times b squared, right? And when I pull all those things out of the box, I get 5. I can only pull 2 of these a squareds out of the box. And so it's like 5 a times a root of a over b times b times b. If there's a better way you guys know of thinking about it, then this is equal to 5a squared root of a over b cubed. Yes? No? That's what you should have got, is this. So, okay. You get that, Meadow? Sort of, maybe? I don't know. So let's keep going. Oh, maybe you could do this one. I bet you could do this one. Okay. So try this one. Whoops, wrong kind of paper. Let's try this one. Maybe work with the person next to you, okay? And kind of talk to, why don't we just do one whiteboard and see if you guys can figure it out together. 81, actually, 81x to the 10th, the whole thing, over 16y to the 4th, like this. That's a perfect square, okay? So you should be able to get that one. Give that one a shot. Go ahead. Okay, we're trying this one right here. You try. You try. Pull out what, I think you could pull out everything out of the bottom, but you can't pull out everything out of the top, right? Is that right? Yes, Jessica. Very right too small. That's correct. Very good. You got it. Go ahead, Chase. What do you do? 4x squared. Yep.
Oh,
Yep. That's correct. What do you get? I can't see something. Right here. Yeah, that's right. Wait, I think you almost, you have to leave something in the box. Hey, 4. What's the cube root of 125? That's, I think that's right. Yeah, that's right. 9 to the 6th, that part's wrong. You're missing something. Hello, yes. Okay, for the most part, those are pretty good. Let me go over this. Where are we? So I didn't unpause. For those of you in our viewers' audience, this is what the answer was. Okay, if you see something that looks like this, 700x divided by 7x, square root of that, you do not need to do the square root of this and square root of that. What can I do first? Does anyone see something I can do first? You can divide things away first to make your problem simpler, right? So 7 goes into 700 how many times? 100 times. And what happens to this? That goes away, right? And I just get the square root of 100. What's the square root of 100? 10, right? So sometimes it's easier to just simplify like that. Okay. If I see, let's do another example, and then we'll move on. If I see one like this, the cube root of 40x y cubed, cube root of 40x y cubed over the cube root of 8x. Are you done with that part?
Yeah.
How was it? All right, okay. What can I do first? Remember that if you have two independent cube roots, I can write it all as one. How many times does 8 go into 40? 5, right? So I'm going to leave a big cube root out here and put a 5 out top. What could I do with those x's? Those x's, you could divide them away. And then I'm left with y cubed up top. What could come outside of the box? Just the y, right? Because the 5, you can't take the cube root of 5, so you leave that inside the box, and that ends up being like that. Okay? You ready for a couple you tries? You tried. Hey, this one's almost the same. Oh, no, it's not. You try. Try. See what you can do with that one. Okay? Ready? For the viewers out there, this was how you do it. You go like this, divide, pull out things out of the square root sign, and that's the answer. Okay? Moving on to something called, this is really important, called rational. You'll learn about this again in geometry, but probably not in as much depth as we do it here. Rationalize the denominator. If you see, this is not too bad. If you see something like the square root of 2 over the square root of 5. What rationalizing the denominator means is get rid of the square roots in the denominator. And there's a reason, kind of a historical reason that you would do that. Back when I was in school, we didn't have calculators that divided these things for you and gave you an answer. So you had to memorize certain square roots. Like I still remember the square root of 2 is about 1.414. And the square root of 3 is 1.732. And I don't remember that because of a math teacher. I remember that from 10th grade geometry because they made me memorize all those things. And the reason that they have you memorize certain square roots is because then I could divide them relatively easily by numbers to get an idea of how big this expression is. In any case, the way that you rationalize the denominator, you multiply by 1, but you call 1 the same thing as it is in the denominator. Because what disappears here when I multiply? Rationalize the denominator means get rid of radicals in the bottom. Radicals in the bottom. Okay, bottom is the denominator. Okay, what's square root of 5 times square root of 5? What's square root of 5 times square root of 5? 5. Okay, because the reason that works is because when I multiply this times this, that makes that into square root of 25, and square root of 25 is 5. Charlie, what's the square root of 2 times the square root of 5? Yeah. It's square root of 10. And then you're done, okay? So now I have no square roots in the denominator, so you're done. That's called rationalizing the denominator. Getting rid of square root symbols in the denominator. So, so let's try another one, or I'll do another one with you. Say I had 3 root of 5 over square root of 2 root of 7. Who can tell me what I need to multiply the bottom by to get rid of? You're not going to, you can do this. Well, what do I need to multiply by? Just the square root of 7 over square root of 7. Go ahead and do that, see what you get. Okay? See what you get when you simplify. Give it a shot. So, there you go, those of you in our viewing audience. There's the answer. Okay? So, I think you could do those. For some reason, okay, they also have you rationalize the numerator. I'm not sure why you would want to do that, but in this book, they ask you to rationalize the numerator, which basically you do exactly the same thing, except you want to get rid of square roots in the top. Rationalize the numerator. Yes, Jessica?
Doesn't that put rationals in the denominator, though?
Yeah, I know. And so I'm not exactly sure why you would want to rationalize the numerator, but we do. Okay, in this book they do. 7, 8 over, so this is kind of one involving letters. How can I get rid of the square root in the numerator? What would I, times by what? Root of 7, 8. Because a root times a root is going to make it disappear. But down here, I also have to multiply root of 7, 8. What's root of 7a times root of 7a? 7a, right? Because this would be 49a squared, and the square root of that is just 7a. And over here, I have to just multiply these things together, so I get 42ab square root, and that's the answer. Okay, that's called rationalizing the numerator, which is slightly different than rationalizing the denominator. Let's try one, okay? rationalize the numerator. You try. Rationalize where I have so these are cube roots, remember, okay? Cube roots. Ready? Set. God bless you. And try this one. Right? Because what you have to do here is you have to multiply by the cube root of 7 twice, right? Because you have to get rid of a cube root, not a square root in this case. I've never taught this before, to tell you the truth. So I haven't seen it much in my teaching of calculus and pre-calculus. But if you did, this is what you would have to do. This turns into 7, because it's 7 times 7 times 7, cube root of it. On the bottom, you get 2 times 7 times 7, which is 14 times 7, which is 28, the cube root of 28. Okay? That's kind of weird. Okay? But that's what they want you to do. Okay? To get rid of the cube root.
Why would it be 48?
Oh, it should be,
14 times
no.
49 times 2.
Oh, 40, right, you're right. Okay? 49, I added instead of 1. So it's 7 times 7 times 2, which is 98, right? Cube root of 98 on the bottom. Okay? So that's kind of tough. All right.